Welcome to most important topic of domain and range of real functions. Here are given some important points to follow while finding the domain and range of such a function, which may exist in the form of numerator by denominator or under root expression or 1 by under root expression. For domain algorithm, the main checkout points corresponding to the format of the given function shown herein. Range algorithm. Step 1. Express x in terms of y. However, exception exists for linear format expressions. Then step 2. Eliminate x by df related condition. Step 3. Find rf like domain procedure. Any impossible output value in the definition of the function must be discarded. Please take the screenshot of the highlighted points that you can better understand by doing different types of problem. Today's lecture L9, we are going to find out the domain and range of some simple real functions. For example, I am taking the first question. Find the domain and range of fx is equal to twice x plus 3 by x. See the solution. Fx is equal to 2x plus 3 by x. Fx is undefined for x is equal to 0. Therefore, it is easily understood that all x can be taken in the set of real numbers except x is equal to 0. So, domain df is equal to set of real number minus 0. Okay. Fx is equal to 2x plus 3 by x implies y is equal to 2x plus 3 by x. Cross multiplying xy and then taking this in this side minus 2x equal to 3. Taking x common, we get y minus 2 is equal to 3. X is equal to 3 by y minus 2. Okay, now x is expressed in terms of y. So, okay, again we see the situation in the denominator. If y is equal to 2, then it becomes 0 and x becomes undefined. See here, x is undefined for y is equal to 2. Therefore, range is the whole set of real numbers minus 2. Next problem. Find the domain and range of fx is equal to minus mod x. Fx is equal to minus mod x. Okay. So x can be taken anything. It is very easy to understand. Okay. So clearly df is equal to all real numbers. See that range is like that. When you put x is equal to 0, then only minus 0 is equal to 0. Otherwise, except 0 plus or minus anything you take, it will be a minus real number. So obviously, range will be this. Okay, from minus infinity to 0 it can reach. Okay, next we are taking one more problem of this type. Look at here, this is also a very simple linear equation. Only difference is that whatever x plus minus you take, it will be ultimately converted to a positive number here. Okay, clearly df is equal to real number. Okay, again we see that at x is equal to 4, fx becomes 0. But for all plus minus x, fx is a positive real number. Okay, how it is? For example, you see that if you take here plus 1, then you see that plus 1 minus 4 equal to minus 3 equal to plus 3. Take minus 1, so minus 1 minus 4 equal to minus 5 equal to again plus 5. Anything like that, it will be real number. So what we understand that range is from 0 to plus infinity. Therefore, Rf is equal to 0 to plus infinity. See this time df and rf of the real function of x is equal to root over x minus 1. Solution, given function of x is equal to root over x minus 1. Here conclusion is that this under root expression must be equal to or greater than 0. Okay, or you can say like that. Here we see that fx is find for if we put x greater than 1, then something remaining positive, and so on root over that positive number will also be a positive number. Okay, so domain df is equal to, obviously it will be from 1 to greater than 1 comma plus infinity. Understand? Now for range, actually you start with some logic. Again, x greater than or equal to 1, we are using that domain condition from here. Okay, and from that we are starting again. X minus 1 is greater than or equal to 1 minus 1, on both sides adding minus 1. Then we are getting x minus 1 greater than 0, imply, see, if this is a positive quantity, then take the square root, it will also be a positive quantity. And this is nothing, this root over x minus 1 is nothing but fx. So fx is greater than 0. And next line you can show also that y greater than or equal to 0. But no need, actually, the fx is nothing but y actually. Therefore, range is equal to from 0 to plus infinity. This is the thing. So you note that domain is from 1 to infinity and range is from 0 to infinity. This is the answer. Okay. Now we are taking one more question, that root over 1 minus x. What happens in that case? Let us see. Here, find the domain and range of fx is equal to root over 1 minus x. Given fx is equal to root over 1 minus x, same logic you must do, that under root expression must be greater than or equal to 0. For domain we must have 1 minus x greater than 0, implies minus 1 plus 1 minus x greater than 0 minus 1, implies minus x greater than or equal to minus 1. Okay, now change the sign because we need to find out the x, implies x will be less than or equal to plus 1. Therefore, df is equal to minus infinity to plus 1. Okay, here closed interval. So this is the df. For range, again you can take directly this one. Okay, 1 minus x greater than or equal to 0. Okay, implies root over 1 minus x greater than or equal to 0. But root over 1 minus x is nothing but fx. So fx greater than or equal to 0. You can write again y greater than or equal to 0. Therefore, range of the function is equal to 0 to infinity. And now look at here. Domain df is equal to minus infinity to 1 and range is equal to 0 to plus infinity.